In this video, we are going to discuss about inter-process communication. QNX inter-process communication, it has a exchange of two processes. So the two processes have exchanges data, control and notification of event occurrence. So between process A and process B, the data, control and notifications are exchanged. QNX supports a wide variety of IPC, QNX Core and as well as POSIX and Unix. So the QNX Core is API is unique to QNX or low level. It includes messaging, pulses, shared memory. The second one is the POSIX. It includes signals, shared memory, pipe, POSIX, TCP and IP. So here we are going to discuss about the message passing. So it's a native QNX message passing. So it's a client server based. So we are having two processes. One is called as the client process. Another one is the server process. We are going to consider these two processes. So client server based. Another one is the bidirectional communication. It will have a communication between client and the server. So the client sends the request or data to the server. That is, it's one, the process one. The message sends from the client to server and server receives and it process. See, message receives from the client and it processes the message. After that, server replies to the client. Client responds and continues. So this is what happening. The first one is the message sent by the thread. The server process, it receives that message, then the message is processed, then again it sends the reply. Here it is the native IPC. Here we are having it's a remote procedure called architecture. So we are going to see the fully synchronous process. So we can see here when it is idle, the server is blocked. When it is idle, the server is blocked. That means it's waiting for message from client. When the client blocks until the server replies. Okay, it will be waiting for server. The client waits for server. The server waits for client. So first the message will be entered. It will be given to the server. The server receives the message from the client and it processes. Again it replies. So at the time we can see here until that it will be until it receives that the client blocks until it receives the reply. So it will be in the blocked mode. So we can see that synchronization and thread states is case one. First case we will see this send after receive blocked or idle server. Okay, we are going to take a blocked or idle server. We can see here this is the client. So we can see that this is the client is there and this is the server. So we are having first one is the both, it's in the runnable state. Client is in the runnable state. So we are going to send the message sent, send the data, that is it's going to send the data. The data will be sent. So at the time the send blocked. After sending the message it will be blocked. So it's the data will be sent here. The message received, that means it receives the data. Now it is in the runnable state. That means server receives the data from the client. So it runs the data. It runs. After that it sends the message reply to the client. So at that time the reply is blocked. Okay. So after receiving it, it will be again coming back to the runnable state. So this yellow line shows the blocked state. So first the client sends the message sent to the server. It receives the message, then it goes to the runnable state. Until that the client is in the blocked state. After receiving the reply from the server, then it is coming to the runnable state. So we can see the connections and channels. So client will act as the have a connect to channels. It produces the client have a client sends to the server's channel using the connections. Client sends to the server channel using the connections. Server is having a channels. Server receives on channels. Client connect to channels. We can see the client is connected to the channel. The server receives from the channel. So we can have a multiple connections and channels. A client may have a client may have a connections to several servers. We can see client A is connected to server C as well as server D. Similarly, client B, the two connections are there. One is connected to that is two connections will be connected to server D. So the message passing, we are having the procedures like a server pseudocode, and also we are having a client pseudocode. The first one is that we have to create the channel, and then we have to wait for the message receive. Then we have to perform the processing. That we have to reply for the message reply. Go back for more. Create the channel, message receive, perform the message reply, go for home. This is what server pseudocode. The client side, attach to a channel, that is connect attach, send message, make use of reply. This is what happened in the client side. The server creates a channel. How it creates a channel means using the channel create. So we can give a flags, that is channel ID. We are going to give a channel ID cheat. That is cheat is that is done by the channel create. The channel creates. The channel is attached to a process. Any thread in the process can receive messages from the channel. So when the message arrives, the kernel simply picks a message receiving thread to receive it. Flag is a bit field. Okay, we will look at some of the flags on the next slide. So these are all the flags: NTO CHF private, NTO CHF coil disconnect, NTO CHF disconnect, and NTO CSF unblock. So these are all some of the channel create flags. Next, channel create. The server creates a channel using flags. Next will be after creating attached, connect attached. So the client connects to the server's channel. This channel is there. The client connects to the server channel. For this we are having connect attach. So PID, CID, that's the process ID, channel ID, NTO side channel, logs. PID is the process ID of the server, CID is the channel ID. So here we are going to connect the coin COID, that is the connection ID. How we are going to connect? So we can connect in two ways. One thing is FD, by using the open file name or randomly we can connect it. Otherwise, or COID, that is coid connect attached, where we have to connect this. In the NTO side channel we can give it. When calling connect attach, you do not want your coil to be in the file descriptor. So when we are using this second one, connect attach, no need to consider this descriptor range. Passing NTO side channel, it prevents. So we want to get the listing of executes or threads in the QNX, means we can go to the target navigator, the information processing system. We can go to the target navigator. There we can view all the states of threads in this process. So on the QNX, we can go to the QNX commands, targets, we can start monitoring. Another one is we can process can be done under QNX targets, target name and process. So this is how it will be executed, and the listing of threads is given here. So thread 1, 2, 3, 4 like that it will be given here. Next will be the message sent. It's for a message sent call our client. So we have to give the like the status equal to message sent, coin ID, S message, S bytes, RMSG, R bytes. Coin ID is the COID is the connection ID. Message is the message to send. S bytes is the number of bytes of message sending. RMSG is the reply buffer. R bytes is the size of the RMSG. Next we are having a message receive, message reply. Last one is the message reply. So RCV ID is the receive ID returned from the server's message receive. Message is reply message to be given to the sender. And we are having message error. So the RCV ID is the receive ID returned from the server's message receive. Call error. Call error is the error value to be put in the error number of the sender. So this is the example of the server program. See there we can have a channel create, message receive, message reply. And we are having the client side, we are having a connect asset, attach, message sent. So we can see here message client serve, that is this client side, this is the server side. And server can reply with no data. So it is also possible. So we can get the status and no data. We are having an exercise based on the server and client. So this exercise will be discussed later. Thank you.